Hi, how are you? Hope you're doing well. Welcome to our lecture series on two-way ANOVA. And so it's going to be a series of lectures because we have a lot to cover. And so let's take a look inside and see what we can expect today. So first we'll cover the conceptual background behind two-way ANOVA. And then we'll look in detail an example using non-recall dataset. First, we'll take a look at some graphs to get a feel for what the means look like and the potential effects. And then we'll get to the heart of ANOVA and see if there are any main or interaction effects. And so I'll explain what that means later on. And then we'll conclude by taking a look at the post-hoc tests before moving on to your turn exercise. And so let's get started. Now last time we covered one-way ANOVA, and it tested for mean differences in one continuous dV. And groups that you're comparing were designated by one categorical IV or the factor. And so this diagram kind of shows you the essence of what ANOVA does, which is to compare the means across different groups. And now we're moving on to territorial factorial ANOVA. Factorial ANOVA has one continuous dV still. However, this time it has two or more categorical IVs or factors. So for example, you might take a look at the effect of marital status and pet ownership on fitness, and then take a look at the individual as well as the combined effects of those two factors, marital status and pet ownership. Now in this course, we will cover the two-way ANOVA. So you might have two independent variables and take a look at the mean differences created by the two factors. Now I've talked about how factorial ANOVA lets you test for individual as well as combined effects of your factors. They're called the main effects and the interaction effects. And so main effects are the direct effect of each IV alone. And so for example, effect of marital status or effect of pet ownership. So those are main effects. And then the interaction effects, as you might have guessed, would refer to the combined effect of the IVs. And so the effects of marital status and pet ownership together. Now what does that mean? Well, let's break it down. First of all, the main effects. So what main effects tell you is whether or not you have significant differences in the means of the dV based on each IV. And so for example, for factor A or marital status, is there a difference in fitness between married and single people on average? And then factor B would show whether or not there's a difference in fitness score between pet owners versus non-owners. So if you're looking at a 2x2 factorial design like this, then you're taking a look at the differences in means created by each factor alone. So for example, factor A or marital status, the mean differences would be between those two categories, married or unmarried. So you're testing to see if there are mean differences there. And then the factor B, pet ownership, once again you're comparing the two means that are created by factor B or pet ownership alone, and seeing if there's a difference between those two means. If you translate that into hypotheses, the main effects for the two-way ANOVA look like this. So the factor A or marital status, the two hypotheses would say this. Married and single people do not differ in their average fitness score, that would be the null. Or the alternate hypothesis would say that they differ significantly. So along the same lines, you might have guessed that the null hypothesis for pet ownership would say pet owners and non-owners do not differ for null hypothesis, whereas the alternate hypothesis would say that they differ in their average fitness score. That's pretty straightforward. The interaction effects are a little bit less straightforward, but pretty sensical if you think about it. So interaction effects tell you whether or not there are significant differences in means of the dV based on the combination of both factors. Now in this case, you have a 2x2 design where each factor contributes two categories. So you get 2 times 2 or 4 different categories to compare. And so is there a difference in mean fitness score between any of these 4 categories? So married people who are pet owners, those who are not, and then single people who are pet owners and those who are not. And so if you look at the 2x2 factorial design, then you are now looking at the 4 means that are created by those 2 different IVs combined. And so you're testing for interactions and looking to see if there are any mean differences across these 4 means inside the 2x2 table. Translating into hypotheses, so the interaction effect for two-way ANOVA, the null hypothesis, as you might imagine, still says there is no difference. And so there's no difference in average fitness score based on the combination of those two factors. So in other words, the 4 cells that you just saw do not differ. And then the alternate hypothesis says that there is a significant difference in average fitness score based on that combination of marital status and pet ownership. Really, it's saying that there is some sort of a mean difference in those 4 cells. It doesn't tell you where, but there should be some sort of a mean difference. So here's a quick summary of what the two-factor ANOVA is doing. And in this case, the 2 factors have 2 categories each. But if you have more than 2 categories for either of the factors, you can keep on increasing the cells and still apply the similar concepts about which means are being tested. Now, taking a look under the hood very quickly, this is a diagram of what the two-factor ANOVA is testing. And so the stage 1 up here is very similar to what's done in one-way ANOVA. So you might remember that the total variance in ANOVA is broken down into between treatments or between group variance, and then the rest within treatments variance, which sometimes is called error. And then in this case, in a two-factor ANOVA, there's stage 2, where the between treatments variance, or the variance accounted for by group differences, is now split up into factor A variance, factor B variance, and then the interaction, and so the effects that we just talked about. And so if you're curious about the math, you're more than welcome to take a look through these. But here are some notes about how stage 1 that you were just shown are broken up, and the formulas that you can use to calculate the between treatments and the within treatments variance, and then the total variance up top. Now, the degrees of freedom are given to you in our studio, and so you don't have to worry about making those types of calculations either. But if you ever need to do calculations by hand, then you have these equations. And then the stage 2 are broken up into the main effects and then the interaction effect that we talked about. And so I've summarized them here. Now, you might remember that the F statistic is a ratio of the mean square between and the mean square within. And the mean square is sum of squares divided by the degrees of freedom for that component. And in this case, for two-way ANOVA, F is calculated for each hypothesis. And so you have one for main effect of factor A, you have another F statistic for the main effect of factor B, and then finally, the F statistic for the interaction effect. And so you will be looking at 3 different F statistics and 3 different tests for these components. So lots to look forward to. And so we'll pause for a second before moving on to the next part, where we'll move into the demo using the non-recall dataset. And so go ahead and please feel free to take a break, and then let's reconvene and take a look at non-recall. See you shortly.